Welcome! In this video I'm going to try to repair this beautiful early 1960s tube radio. It belonged to my grandfather, but he has spent the last few decades just resting on a shelf in my house. When I was a little kid I would turn it on every once in a while, hoping that it would magically come back to life, but it never did. So I thought it would be interesting to finally get to fix it. If I manage to, because I must say that I have no prior experience dealing with tube-related electronics. So it's definitely going to be an interesting learning experience for me as well. Let's get started, shall we? When I turn on the radio, all we hear is this very loud buzzing noise, regardless of the frequency or the mode that is being selected. The keys are a little bit stuck as well. Let's begin by opening it. Inside we can see all the internals as well as the model and the serial number. The radio now is out of the box, and the first thing we have to do is to clean it. I then proceeded to take all the tubes out and clean it to a point where it was not disgusting. I even found a dead spider in it. I do not own any kind of specialized equipment to check the tubes, so I'm just going to do a basic multimeter test. I'm going to check that there is continuity in the filament, so it's not burned, and then I'm going to check that there is not any unwanted continuity anywhere else. I then proceeded to check all the other tubes, but I couldn't find any fault in them, so I don't think they are the cause of our problems. After checking all the tubes and finding no fault in them, I'm going to look for obvious damage, broken connections, damaged components, etc. Now, the first thing that we immediately notice here is that this capacitor is completely blown up. That capacitor is this one over here, the C51, which is connected parallel to the mains for some sort of noise suppression, I guess. Now, it's pretty obvious that this is not what's causing the radio to malfunction, because it's just a capacitor connected in parallel to the mains. Still, we're going to change it and continue forward with the repair. You can see how damaged it is. Let's put a new one and go on to tackle the main problem. I recorded the buzzing noise that the radio was making, and if we zoom in, we see that the frequency is 50 Hz. Is that a coincidence? Yeah, probably it's not. It's 50 Hz is the grid frequency. Now, if those two filter capacitors are bad, then the 50 Hz grid frequency is going to leak into the speaker transformer. So my guess is that those two filter capacitors are bad. Just to make sure, I'm going to tap into one of the supply voltage lines, which should be filtered. And we can see as the tube heats up, it's completely unfiltered. The capacitor is not even trying. The filter capacitor, which is actually two capacitors in one package, is, old and has its special charm. So instead of removing it, I'm just going to disconnect it and put two new capacitors under the chassis. That's the end result. You can see here the 100 microfarad capacitor. This is the 47 microfarad capacitor. They are taped in place and hopefully they won't short anything. Let's test it.
Fins al 2014 recull aquesta evolució de la participació en la vida social de les dones a partir de 6 indicadors: la matriculació en estudis superiors, la presència en el mercat laboral, l'edat mitjana de la mare, el naixement...
So yeah, it works. Now it's only about cleaning the most visible parts, putting a little bit of oil in the moving parts to ensure a smooth operation, and putting everything back together. So we are done. It's fixed, up and running. In the end, it turned out to be way easier than I expected. Now the only thing that remains is to fix that wooden top, but I'll leave that for another day. And well, we've contributed to lowering the entropy of the world, which is always a nice thing to do. Thank you for watching.